Hello, everybody. My name is Kevin Kawchak. I'm the founder CEO of Chemical Q Device. I'm here today to talk to you about a quantum technology timeline with 235 resources and additional details. Now, the reason why this is so important is the news keeps getting broke as far as like all these different aspects in terms of quantum computing, cybersecurity, networking, sensors, algorithms, and you're hearing it from government, academia, and industry. So I'm here to try to make sense of all of this. So I'll give you the conclusions up front, and I'll post these at the end too. So basically, quantum technologies started with the government. A lot of people think that industry, academia, obviously these are tight partnerships, especially with government and academia in the earlier days. And it's going to be a part of electronics going forward, certain applications, trying to figure out very tough weather problems, transportation, finance, kind of the easier problems we'll tackle up front, as an industry. And in specific, the partnerships that have formed, a lot of them have expanded. And the one that comes to mind is BMW. There's also Andretti Racing, kind of these fun projects where they're trying to, take advantage of optimization problems and going into, many applications that have been funded, and just don't forget about the many things that are going on. And what comes to mind is Rigetti. They have fusion and weather projects that we'll hear about, but then you won't hear about for a while. And a lot of them are sufficiently funded. So there's a lot of abbreviations that are used to cut down on verbiage. So here's a list. If you need to, in the attached deck, you could basically take a look if you're confused. So I started this basically in October of 21, the Southern California Quantum Computing Discussion, and I would research it a lot. So October, November, December, and even going through this year as well. And kind of over the course of this time, I've been able to determine the impact a specific article has on the overall technology. And it's also important to keep in mind these things as far as, how are they scientifically relevant in today's, going into advanced computing, hybrids, accelerators, these types of things. And then also, I also include things that are kind of new, kind of unique and different, a little bit off the beaten track, that shows kind of like the culture of quantum computing and all of this coming to fruition. In specific, in these articles, I include PDFs, videos, and patents, and they're color coded. So if you want to go back to the slides that I included, these 235 resources, you can. So if it's blue, magenta, or yellow. Now, in the early 1900s, not a lot going on in quantum. Now, we give credit to a lot of these people. So Albert Einstein, Max Born, Schrodinger, in specific, with a lot of these kind of earlier developments, kind of like the paperwork behind it, trying to figure out this new thing. Basically, when you get down to really small, distances, you're dealing in the quantum scale. And as Albert Einstein once said, spooky action at a distance. And that's what we want to try to take advantage of for these problems that earlier this month, they're saying, microseconds to figure something out instead of 9,000 years for a very specific task. And that's one thing I wanted to kind of convey with this, is that a lot of these developments are very specific problems. In specific, we've made advancements as an industry in cybersecurity, and then also with quantum annealing, which is optimization problems as well. So NSF is basically the de facto organization as far as like the early days. So I included a couple of these grants on general relativity, quantum mechanics, and random fields. So you can check out, you can click on any of these different numbers. So this is obviously resources 1 through 5. So Richard Feynman and John Martinis, I've heard in different, I've gone to so many different quantum events, and they say in specific, like whoever's the grandfather of quantum, and you'll hear this Deutsch Jose algorithm being brought up. So it's important to kind of see where all this came from. So you'll hear Feynman, you'll hear Feynman passed away. I think, about 10 years ago, something like that. And I included an article on that too. And John Martinis is still alive, and he was part of Google Quantum Supremacy in 2019, October. Now, it's just good to have a background of where all of this came. A lot of these algorithms, they say like, now it's a hybrid, Joyce Jose or hybrid Shors or some of these kind of ones that you hear as far as the potential to break encryption. And you could take a look at some of these, there was NIST organizes their first quantum conference. And a lot of these people, and I've had speakers on that, there's a gentleman, Salvador Ivanegas Andreca. He got into quantum in 2004. Now, John Martinis was about the early 80s, and his first paper was the month that I was born, 1983. So as you can see, these developments, they're just interesting to see. A patent computer for a quantum computer, I believe that's Feynman's, and you can click, or actually, no, that's a patent. So that's one of it's very interesting. A quantum computer is an array of quantum, bits, qubits together. So you could take a look at that. And then also you could see as these things progress into, more patents. And then this whole idea of a quantum internet. And actually this month, we're starting to see a lot of quantum communications. I'm looking at this 1415. With University of Chicago, and then in Washington, D.C., with a lot of these things, as far as, it's short distances, but basically, opportunities for teleportation where you have transferring of information from one place to another with no record of anything going on in between. And again, when you look at things at the quantum scale, it's just everything acts in a quantum mechanic mathematical behavior. So moving on. So this Caltech one is interesting too. So this is actually a PowerPoint. And then this is basically saying how you can get these quantum algorithms to speed up. And that's through additional, kind of interference. You could read that one. I would recommend this website, Quantum Algorithm Zoo. Now, Quantum Algorithm Zoo has been around for a while. I think this gentleman, S. Jordan, I'm looking at 16, he basically work this up in a similar fashion to what I'm doing here with the timeline, just like every different type of quantum exponential, quadratic, polynomial algorithm out there. A lot of people don't give, we're looking at D-Wave here on 611, is they were around since around 2000. Now they started off thinking they could do superconducting qubits, which is the most powerful, and then to switch to quantum annealing. And they sold their first one to Lockheed Martin in June of 2011 for $10 million. You see other huge clients that they've had: NASA, Google, Toshiba. The list goes on and on. And their stuff works. It's for optimization problems. It's not the best or the fastest, but if you're looking to use some type of quantum computing for finding local minimums in specific types of projects, D-Wave is out there. And there's been kind of like a little, so the RIM co-founder, so we're talking BlackBerry co-founder, Mike Lazaridis, has gone 100% into quantum. I'm sure he does other things too, but if you look at University of Waterloo in Canada, he's a big aspect of, they basically built a building adjacent to the university, to help with, startups like mine that focuses on healthcare data and medical devices. And I'll get to another accelerator as well. And you should check out this book, Scott Aronson's book. So he's been in it since, before 2013. It's been recommended to me by many different people as a source of humor. Now, in this page in specific, you could just see these types of things just all the good news, right? And in specific in the earlier times with academia. And then it appears to me when government makes a huge jump, the industry follows, and you'll see that apparent in some of the other funding examples here too. Now, in this 914, Martinis was commissioned to build a quantum computer that had better performance than a classical computer, and we call that quantum supremacy or quantum advantage, quantum speed up. It's many times you can use a quantum computer, but either classical could do it, better, faster, cheaper today, or say in 5 years, because classical is going to get better too. So the whole point with all this quantum is to have things that are exponentially better, problems, say for instance, finance, transportation, that are much, much better, that classical in theory would take thousands, millions, billions of years. And that's not every problem, right? So that's the hard part, is figuring that out. I would suggest if you're an investor to check out this 21 link. In specific, they list all of these quantum computers, nearly 4 times as many quantum computer funding rounds in the last 3 years compared to the previous 14. And this was in 16. So it was heating up back then. So it's taken years and years, for this funding to, yield, technically viable things. So this resource 22 here is interesting because trapped ions is probably the number one, if not towards the top, rental on Amazon's cloud quantum service. So it's just interesting. They say trapped ions are a bit of a black sheep now, but I think in the coming years, people will be flocking to it. And that's in 2016. So in 17, 18, this is Trump's National Quantum Initiative Act. Obviously other people around too, but it sent a big message. And I think this is what kind of like helped, this is, the government, really stepping in with quantum, and the government believes in it more than probably anybody else. So you see William Zhang, he's with the Popular Bank. And this is, for instance, one of his, it's the most cited article, it's 24. And then IARPA, just 10,000-fold increase in speed on hard optimization problems. So anytime you see optimization, you're talking about annealing. And this is the type of technology that works pretty well these days, and it's getting better as other technologies are trying to work, period, because they have too much error and they're low fidelity. I found this 26. I would definitely check this out. This is the CCECQ. It has to do with algorithms and like different combinations, and they list the specific papers that use these specific ones. So over the course, since of, 417 and before, basically. Okay, so you see all this news here. Now I would check out, so some of these are D-Wave. You see the optimize quantum annealing number 28. I would check that out. They post a bunch of different PDFs. And again, say for instance, like IBM or Rigetti, they have this super powerful technology, but they're still trying to figure out the error or basically it's just low fidelity. And some of these other ones too, this election modeling is very interesting. It has a kind of a history behind it too. You see the names kind of change as far as like, people, different companies buying out others, but this is an archive in there too. So they have a nice PowerPoint, and they also have a nice article with it too. So that's 29. And then you can also see this room temperature quantum, kind of application NSF, right? National Science Foundation. So in some of these other ones, you have to, I've heard about this book. It's William Hurley. He goes by Worley. Quantum Computing for Babies. Now, I'm assuming a lot of adults, including myself, could benefit from this as well. A programming and coding book for kids. And it's been tossed around. So you've got Scott Aronson's, you've got his, or you've got Worley's here. And also you see Feynman. So we mentioned Feynman earlier, is Nature did a huge feature on him, and it kind of like goes through his golden years, these types of things as well. And in 918, you start to see all these really cool US government publications on quantum. I would check this one out. There's another one about, basically our perspective on, international talent, hiring, workers across the globe. Very interesting. So I mentioned before, so the two things that are kind of working right now, we have communications, between this like a Washington, DC network. We have it's Fermi Lab to Argonne National Lab, in Chicago as far as those communications too. Now, ID Quantique, they do hardware-based quantum security. So if you didn't know, there's been 3 Samsung Galaxy quantum phones, and they say they're the most secure on the planet, and they use a little chip called a quantum random number generator. It's about 2 by 2 millimeters in size. Now, everything ID Quantique's been around for a while, so they're saying here that's the biggest thing is how many kilometers can we pass quantum information. So the issue is obviously the temperature, humidity, these qubits over long distances, and they have to use repeaters and all these types of things. So I would check out 35 if that's something you'd be interested in. So the DOE is I'll get to DOE and kind of like the later ones, but basically NSF, DOE, they're kind of like the big ones with trying to get developments out of quantum funding. So this is the big one. So October 2019, 77 authors in a Nature publication, and it sparks controversy. It's they say it's a similar thing to what Xanadu said, that we did a specific task in a certain amount of time that much faster than classical could do. And again, these aren't fully functional computers. It's just a specific thing. And there's Volkswagen worked with, basically this article, I think it was in Lisbon, and, trying to do these proof of concepts, first pilot project for traffic optimization. So there you go, optimization. Now, if you're, startup or an investor, I would take a look at this, Quantum Gold Rush and Nature. It'll give you specifics in that time period. I know a lot of people today are, focused about this, but it's, history is definitely good to know. Big banks, most of the big banks have posted, information on quantum as far as, their direction and where the types of projects, not specifics, but they're definitely funding it. And then, you see, kind of quantum chemistry. Now, there's probably the most applicable is called financial. You could, include like medical data too. Anything, looking at classical data, like just converting, real numbers into irrational numbers. So quantum computing uses irrational matrix math, and then also complex numbers, quantum mechanics, and linear algebra, like matrix. So I would check this out. So 42 in magenta there. So this is the talk a month after quantum supremacy on the previous slide. And he looks like he's been working really hard in this one. You just have to fix everything to get it to work. So I would check that out. It's by Caltech. So you start to see these innovations. So, basically November 2019, IBM and Wells Fargo. This is kind of like an earlier one. There'll be more bank ones I'll show. And then this, NTT with all these different, 8 of the world's top research organization. So if you haven't gotten it yet, it's like the world has, especially US, even there was a quantum Latino one in, Latin America a couple of weeks ago, but there's Spain, China, there's just many countries that are fully vested into this technology. Now, this is a quote here, quantum computer will be the smartphone of the 2020s, of bank strategists, and you can read that article. And then if you're a programmer, if you're working on this stuff, if you want to learn from somebody, I think he's, Python, you could check out 46, definitely too. So there's been, like I said, some fuss, right? Because like the world just thinks you can have a drop-in quantum computer, a drop-in quantum chip for a CPU. It doesn't work like that. It's kind of like the best explanation I've heard is like it's going to be like a GPU. So you have a CPU, central processing unit, graphics, processing unit, and now you have a quantum processing unit, a QPU. So CPU, GPU, QPU, and there's big articles as far as 76% of HPC high performance computing will use some aspect of quantum by the end of 2023, which is the year a lot of people are saying. So I would, it's just interesting. Like the history of this is like they say instead of using supremacy, use quantum advantage, right? Because it won't for every case be better than classical, and classical won't be better than quantum. So that was kind of like the turning point there. So you hear those three, you don't hear supremacy as much, but there's all these other terms that, people use related to quantum. So, quantum speedups, these types of things. Now there's a bunch of big papers. So this quantum computer systems for scientific discovery. This is when, like not many applications and, still trying to figure it out, but it's a big paper, 24 authors. And this is an archive. Now it has been mentioned to me, not a lot of these are peer reviewed. And that could be, it's for a number of reasons, right? Because like, everybody has to understand these things but you'll see a number of archive, XIVs. You'll see Nature's, a lot of those, Science, but you could search for the rest of the top quantum publications. This is like academia. So NSF has been handing out a lot of money, so $25 million to each of these universities. So it's just a very they're 100% into quantum, more so than myself. So you could take a look. Oh, CNBC, number 50, that video in magenta there. Check it out. It's very interesting. They talk about caffeine, the number of qubits it would take to just model caffeine inside a quantum computer, like 162. And then for penicillin, you're talking about, approaching more than the number of atoms in the universe, right? And that's where quantum excels, is with like quantum chemistry, quantum physics, and these fall under quantum mechanics. So this number 51 is interesting because, basically it shows there's movement, right? So there's a bank trying to get this IBM master inventor, right? Everybody wants to stay ahead with encryption. Now on IBM's website 52 there is basically, they're trying to, or they're working with a bunch of different companies with this. Now, I mentioned Salvador's name here too. This quantum image processing, it's referred to as QIP or QIMP. But, it says, in Amazon, there's just so many aspects of quantum. It's not just quantum computing. You got, quantum algorithms, there's security, there's everything, right? So a compound annual growth rate that I get a lot in searches. And again, I look at Google alerts almost every day for quantum computing and quantum algorithms, is about 30%. Now you have to look at the forecast definitions, say a certain range, 4 years, 7 years, something like that. But I included this one because it seemed like it was like somewhere in the middle, and a good median actually is about 30%. But I'll get to another one here that's higher, but that's a different, there's all different types of, you have to be careful with the terminology that's used. So if you look at a lot of these, now this is a patent 56, and I would check this one out for sure. Method for injecting human knowledge into AI models. Now, if you search for Google search in patents, let's say quantum, AI, those types of things, 9 times out of 10, they just list quantum once or twice. And it's just like, oh, it could potentially, but you want to look for the ones that include, big paragraphs that mention quantum, several times. Now, this whole industry has grown, and you see 12 women pioneering the world of quantum computing. And, there's features like this all over the place. There's an organization called One Quantum. There's a company called Qureka, Araceli, was just a speaker on SoCal Quantum. And then so she runs that organization, but it's a good sign that the industry's, healthy and going places as far as diversity and, these types of things as well. So MIT, quantum medical imaging. Now, as I mentioned before, we're looking at 58, is that basically there's a lot of things you can do just fine and dandy, classically, and then don't even bother. Now, when you're dealing with like, I don't know, zettabytes or whatever of information in the space, these types of things, and you're trying to do image processing, that's where quantum shines, right? So this is medical imaging, say I think it's more than that, but X-rays, MRIs, these types of things. You've heard of AI be used quantum or classically, like conventionally. But yeah, it's basically you're trying to find things with a quantum computer that can never or can't be done in any appreciable time. I like these kind of like international ones too. So this is Cicero on 59. And they said the quantum technology sector could support 16,000 jobs. And there's other good financials, $4 billion, these types of things. Now in 60, this is One Quantum. And actually, Andre M. Kodag, who helps lead this organization, was just on the discussion as well. And you see, so Denise Ruffner is kind of a pioneer, and she does really good kind of like she breaks down like, if you're looking at like how many quantum computing companies are in this type of technology. So, but yeah, One Quantum, definitely good to check out. And you start to see DARPA. So DARPA in specific, it says a kick off the quantum computing program with teams. We're in like May 2020 here. And then IBM exploring, this is actually a PDF. And then I ran into Dr. Frederick Flother, and there's 3 other people on this paper as well. But it's a good overview, getting into these things is, if big pharma wants to do all these, simulations inside a quantum computer and not even, go to the lab at all, that's probably a while away. But as far as just, looking at classical data, maybe a little bit sooner. So I thought this was very interesting, 63. Now, superconducting qubits is kind of like what people hope will work the best. Now, it has a big issue with error. Like, it's theoretically the most powerful, but it also has more error than, say, like ion trap and definitely, quantum annealing. But you can do many, many things that some of the other technologies can't. So I believe actually the summer school is, the summer is called the Quantum Computing Error Correction School. So imagine sending your kid to error correction school, but it's that big of a problem, superconducting qubits. Now, there's been bits and pieces as far as global warming. So Rigetti's has some funding with this too. So we're looking at 64. And this 4,000 logical qubits is a while away, but they believe they have the algorithm, to help, help impact global warming. So you look at some of these other ones, you'll see the big banks in specific are JP Morgan Chase is #1 in certain aspects of, quantum, and that's July 20th. And then you see partnerships. So I wrote a report, I didn't release it, but it was like last year, 2022, the year of quantum computing partnerships. And I would say probably even more than this year. And this year we're starting to see kind of other breakthroughs. So here's in 67, NSF establishes 3 new QIS, so quantum information sciences, quantum leap institutes. And it's just like the amount of involvement. And I saw one of their, program directors going to Penn State, like, basically like a couple weeks after they received like a $700,000 grant, and Penn State's, doing this and that with quantum. And, you have Fortune 50 announces general availability of quantum cloud. So, basically with all these announcements is Amazon's AWS, their cloud service that a lot of people use with conventional computing. I think that was, let's see, it was later in 2019. So the 69 that I'm looking at is basically opening it up to more people. Now the 70 is huge. Now a lot of things, it seems like it spins off of this, but it's $1 billion with artificial intelligence, quantum computing between NSF and DOE. And, basically that an unprecedented investment is what they say. So you hear other big names, Berkeley Lab, Toshiba provides icing, but focusing on the company names, big company names, and specifics is always good to see. Now this QEDC, which is Quantum Economic Development Consortium, actually is a spinoff, or it's part of the package of that Trump National Quantum Initiative Act. And basically NIST is it's complex, but NIST is heavily involved with this QEDC. So its aim is not to make competitors. Its aim is to bring everybody together so we can figure this stuff out in general. So, they have webinars and all these types of things that you pay a small fee for your startup or company, and then you're part of this Washington, D.C. kind of based consortium. So there's nuclear physics or nuclear computing. So I believe this is, or you have to check that one out, but you can see just the breadth of the technological developments going on. So I thought this is interesting. So again, some of these papers aren't the hugest as far as the journals, but quantum for prediction of cognitive state of human mind from EEGs, right? So you're taking EEG data, and that's a huge thing, right? Like we want to understand the mind better, and quantum can detect certain things, better, or maybe it doesn't even require liquid helium cooling, so you can put it closer, that kind of stuff too. So you see Zapata in here too. Now this is an interesting, this 77 is done by Accenture, and basically say 97% of survey respondents are optimistic. Now I'm going to get to it too. Chuck Schumer, has been involved with upstate New York as well. And you'll start to see it's just the numbers being thrown out as far as funding are pretty substantial. I would definitely recommend, there's been a number, I think at least 3 or 4, probably more. McKinsey reports are really good. I saw a pharmaceutical one. This is number 78 is more financial. So when you look at some of these other things, so number 79 is a specific thing with D-Wave and GE. Now they're just throwing things out, like it's a case study, and they say all this stuff is 106,000, possibilities, for 79. And here's another one for 2021, exploring EEG with a model inspired by quantum mechanics, number 80. And then you have 81. This one is kind of interesting because it's kind of specific. It's a waste collection optimization study. Again, they have a bunch of these PDFs up, and they said for their specific case, 57% less CO2 emissions, 59% less vehicles, and then a reduction from 2,300 to 1,000 kilometers, for this specific thing. So you would want to reach out to D-Wave to get that, as far as I think this is just like a projection, but these PDFs are available. So this is another big paper, Nature Methods, number 82, and you see 17 authors, and these papers are just big, right? So I don't think they're just looking for stuff to do. Now you see in 83 pharma, and then you also see so this 84 fiscal year 2021, that was a big one. They have a fiscal year 2022, which is also in here too. And then as you kind of see, this is a world thing. I had mentioned the Samsung Galaxy quantum phones. I believe those are for Korea, but they say they're the most secure in the world. And so in 85, you kind of see that South Korea and one of our hardware manufacturers. In 86, you see, basically one of the biggest, I think in some cases they are the biggest, pharmaceutical for drug discovery. Now there's a number of companies out there. You have Polaris QB, you have Metin AI, you have Janssen, which is Johnson & Johnson. And they're doing the really hard stuff, but we don't have the hardware for it because they have to make approximations and, you know, flatten things, like take a 3D molecule and flatten it, that type of thing. But it's still, you know, productive research because as one of the experts that I watched when I first looked at this said, it's like a hockey player taking a slap shot. Any one of these technologies could take off. So 87 is another D-Wave study with traffic optimization in Toyota. Didn't get too much out of that one. Now, 88 IonQ is the first ever. So that's March. They announced $2 billion SPAC. And then they IPO'd October 1st, 2021. So these are $1 billion. We have 3 pure play quantum computing hardware manufacturers that have $1 billion or plus SPAC deals. This 89 is a short, it's like a 2-page thing from Nature. It's a little, you know, it just breaks things down kind of like simply. And this 90 Cleveland Clinic and IBM is a huge thing, 10-year deal. I think that's the only one that's that big. I could be wrong, but it says it's the first private sector on premise IBM quantum system one in the US, basically kind of, you know, forward thinking in healthcare. So there's stuff in DNA. It's not awesome. You know, I haven't heard too much of this recently, but again, if I think one of the Nature articles I'm looking at 91 is, you know, say if you have like billion base pairs, they're at 6 or something like that. So, but it's kind of baby steps with quantum optimization. So you see Air Force Research Laboratory is really involved with quantum. They do their own kind of the little experiments with, you know, photonics. And then, you know, anytime you see Amazon, AWS, and the specific thing it's called Bracket that they have, BRAKET, is that, you know, more and more people, Classique, June 2nd this month in 2022, they just announced that you could do things you could never do before on Amazon. And then, you know, you have 94 PsiQuantum. So this is kind of like first full-scale quantum. I think this is the Chuck Schumer thing, but you have to check that one out. So 95 Xanadu, 100 million, 96 Forbes milestones of history of quantum. So a lot of these, you know, I've kind of covered from, you know, different sources. NIH does obviously health related. They say it's advanced computational approaches, as you know, they don't say quantum, but it's kind of like an implied. So there was other things in 98, Google unveiling new campus. You could check out that article. 99, smallest trapped ion based computer that fits in 2 boxes. So I mentioned as far as like, typically the more performance, the more error, not always the case, but another thing is size. Like even the quantum annealing that I mentioned before, that is 3 refrigerators size, right? Unless they made it smaller. But a lot of these are still pretty big, and a lot of them take cooling, like down to millikelvin temperatures. So you start off with liquid helium and just go down. Now, what's interesting right now is the communications. Like I said, there was just like the Fermi Lab and Argonne National, you know, in DC, there's stuff going on as far as June 2022. Now in June, you know, 21, Toshiba says 600 kilometer, you know, quantum communications as well. So that's an aspect of quantum you want to keep an eye on, you know, not just computing, which tends to take most of the headlines. So here's another good one. So 101 we're looking at, and basically this is a DOE feature, Women of Quantum Computing feature, and it has a number of good quotes in it. I definitely recommend checking that out. 102, 2 leading advocates. So basically this is IBM and StrangeWorks. StrangeWorks is the Worley who did the quantum computing for babies. And then here's this is the one I was talking about, Science Reports, which is like Nature. Number 103, General Assembly. And it's interesting, like baby steps for a lot of this stuff, because if you think of like simulating molecules, not quantum simulation, but like simulating molecules and super powerful quantum computers might not be right now. So here's another McKinsey report. This was one of the first ones that I read. I formed a provisional patent on a quantum-based medical device. And this specific 104 was one of the first ones. It's very comprehensive. It's got good illustrations too, kind of graphics with it too. 105, Rigetti, is basically this the second pure play, meaning not IBM and other manufacturers that were around before all this quantum stuff. But again, another $1 billion plus SPAC deal. And I think they, maybe like 2 months ago, they IPO'd on NASDAQ, right? The big thing. So 106 is John Martini. So I had mentioned him before. Basically, he's one of these, pioneers in quantum computing. Just many articles. He was at UCSB. I think he's still affiliated. Like I said, he was in the Google Supremacy project, but I think he left after that. So you have a bank and a quantum computing hardware manufacturer in 107, 108. This is the fun stuff, right? The launch of this BMW quantum computing challenge. Now, I haven't seen much as far as like, this car does this better, faster, cheaper, whatever. But them and there's another one. It's a green one of the green quantum companies is with the kind of like the Indy cars. So this is like the BMW stuff. And then, so you also have Rigetti, partnering with Riverlane is a quantum computing operating system, and they want to run on any different type of quantum technology. There's at least 9 quantum computing hardware technology out there. And this is pharmaceuticals. So big pharma wants it, right? But like, as far as like having these, it's called high quantum volume, which is high qubits and low error. We're just not there yet. We're at about like 4,000. And then this is a lot of these COVID ones, you really have to look at closely. It's not what you think it is. A lot of times it's like, oh, we'll fix the transportation so that you can spread out more in COVID, that kind of stuff. But I think this is more direct on this one, this BMC Medical. I checked it out, but again, if you look at percents and figures and all these types of things, it's not like a shocking thing. Here again is another DNA one in 111. And they're interesting to look at because the method could work, right? It's just the computer, the hardware is not there. 112 BCG, it's Boston Consulting Group. This is pretty ambitious, $850 billion in annual value by 2040. 113, this is another kind of compounding annual growth rate, pretty high, 30%. So, in my field, well, we won't get into that, but it's healthcare data is high too. So 821 or number 114, Polaris QB is one of those companies that I had mentioned. So basically, this is Shahar Keenan, and she's been a speaker on SoCal Quantum as well. She, it's the kind of thing, it's just like, we all want awesome things to happen, but a lot of times it's just you have to wait for the hardware to come. Now there's 115 is this 80% compound annual growth rate, but it's for quantum computing as a service. Okay. And it's this, TQI website in 115. So you have to pay attention to what these things are talking about. And so the 116, I think this one, Jennifer Granholm says $61 million in specific for quantum. And I'm not quite sure. I think that's from the $1 billion, but you have to research it further. So in 117, this was kind of interesting to me, Polymer Physics. So if you look on, and I'll show you the link, like D-Wave says they've had like over 250 applications. So there's many people that just don't believe in annealing, and everybody knows it's not as like fast or whatever, but check out the papers, right? I'll show you the link. And then everything is kind of introductory. It's not going to be awesome. Here's another QML, or quantum machine learning for COVID-19. So I think I have like 3 or 4 kind of COVID things in here in 118. So you have Verizon in 119 joining a National Quantum Science Center, right? So if you don't believe in quantum, now's the time. So 120 is it's interesting, basically the hard thing for investors is that they don't understand all these technologies fully. So resources like this, or, it's hard to find things kind of put all together. You really have to talk to experts. 121 is actually a thesis. I saw this and I'm like, oh, okay, a suite of quantum articles, sweet, right? For the shortest vector problem. So it's just interesting, right? Because it's like, if you really believe in a technology, then you should be teaching it to not only college, but high school. There's groups, quantum computing groups. I saw a picture and there was Chinese children and they're being taught quantum computing. So 122 is IBM, kind of like scaling, going up. Now 123, if you're super into all this encryption and afraid that quantum computers are going to, break this and that, say for instance, like a different country, has a better quantum computer and we can't protect our, encryption. This says factoring 2048-bit RSA integers in 177 days with, this 13,000 qubits. We don't have those yet, but, so it's an interesting, thing to read. And here's another finance one, QML for 124, quantum maker and G research. So this is IonQ has a ton of partnerships. The technology, it's the most expensive. So when you go to, Amazon's, cloud service, it's the most expensive one, price per shot, so you have to do a number of shots with quantum. So that type of technology, seems to be, doing well, and talking to other manufacturers too. So 126, another bank. So this is a bank and a basically quantum software algorithm. And then 127 actually came out around the same time. This is Goldman Sachs, QCware, and IonQ. And they worked on the specifics thing in this archive paper, 127 in blue. And then there was also a paper, I believe it's on here too, it's Fidelity and IonQ. But as far as like the big names, and I'll get to it too, basically IonQ was basically one of Time's top 100 companies as well. 128, this other Quantum Machines is a company funding around. And 129 is specific thing, optoelectronic quantum technologies. 130, if you're really into this kind of like the theoretical stuff, is very interesting, is that, a lot of people say this can't be broken as far as this theorem. And now it says it holds not just for absolute zero. So in quantum computing, we want to get away from really cold cooling, because it takes a lot of, it's costly energy to, extract helium, from the air. So 131, this is QCware. Also kind of a thing coming up for QCware. They have Q2B. They have their big annual conference in Tokyo this year. So I believe it's in July. So it's right around the corner, and I just got the announcement. So if you're looking for big things to go to, you can go to QCwares. 132, again, on the IonQ thing, they're basically with University of Maryland. They've had a number of big papers, and this is kind of the announcement. No other university in the United States is able to provide students with all this. So 133 is the 2020, there's $1 billion in VC deals in quantum. 134, this is the IonQ and Fidelity, and this one is focused on machine learning for finance. But figure there's so much in the pipeline right now as far as, the number of articles. So HPC, high performance computing is, it's conventional, but, the industry is trying to put quantum aspects into all these supercomputer centers. you know, like functionally, and it all works out. So 136 is actually River Lane. They want to do this universal operating system for quantum. 137 is another IDQ. So just to see that they've made it to fourth gen of this, you know, quantum-based encryption is very encouraging. These things you can get anywhere ranging from USB drives to PCI cards, like those things that plug into desktops, to you know, rack mount systems, which I think this is what this is, this 137. 138 is basically what I was told is like, we have the algorithms, but we just need the hardware. So you can have these 100 times, you know, better banking algorithms, but you need the hardware to go with it. Now, 139, it is the first, it says to build world's first. And then later on, I'll show you kind of like an update to this, but this is quantum security. It's quantum networking, basically, kind of like the buzz, you know, this month is kind of like the quantum communications. 140 is interesting. Not only was it Amazon, Google, Microsoft, but a bunch of others listed at 140, and then some others as well. And then you have, here's another quantum machine learning. So I would definitely check these out. I mean, it's not always, I think that was just one article where it was just like, not directly, but I think this is patient data using QML. This 141 is probably worth checking out. So this 142 I mentioned earlier before, as far as if you look at these things, maintaining leadership in this critical emerging technology will depend on growing a diverse and expert workforce. So it's worth reading all these things. Now, 143, Raytheon IBM. 144 is, you know, quantum computing with batteries. Tom's Hardware, this is 145. They've started to develop all these things and show the different types of technologies. You can check them out. And, you know, they'll compare ion trap to superconducting to all these types of things. So 146 was a big paper. This was kind of like the big paper, the first kind of big paper that I found that nobody else knew about. So it's basically fault tolerant is like getting to the point where the error isn't horrible. But this is on ion Q, or this is on ion trap technology. So the kind of the big ones seem to be a lot with that type of technology. And again, the size doesn't seem to be that large. And, you know, the people don't want things like super cooled. So it's worth checking all these things out. So 147, more quantum key distribution. So you have 148, nation's first quantum accelerator. So this is actually duality. This isn't quantum accelerator. This is an incubator, basically. So if you're looking for it, I hear they give you like 50K up front, and you have to be like housed there. You're in Chicago, but it's very happening place right now, especially with communications. And if you look for a lot of the previous grants, Chicago's gotten them, you know. 149, it's this quantum instrumentation control kit. It's just very appealing. 150, it's talking about noise. So it's a phys.org, that one. So if you look at, so 151 is more kind of like theoretical with physics. 152 is all this stuff. So again, you know, a lot of these things, just INQ just keeps popping up. Again, they were the first, you know, pure play quantum computing hardware manufacturer to IPO. And then Multiverse is basically algorithms. So they're the ones that said the 100x banking algorithms are here. So 153, so you hear, you know, like Cambridge Quantum, which is basically Quantinuum now, hires ex-White House scientists, right? So you'll see this interplay between, you know, academia, government, and industry. You know, now the industry wants to, you know, these things have been going back and forth, and it's just a really good thing to see. If you look at some of the fiscal year, you know, 2021, 2022 reports, as you'll see that. So this 154 is interesting. They're basically saying, you know, with Spain, you know, they want to be a powerhouse just like the US. 155. So this is IBM and a Korean university. 156, Chicago Quantum Exchange. Yeah, I would say Chicago is one of the hotbeds out there for quantum. And then 157, that I guarantee this is my article, not too many people know about, $1 billion in new research to Australia. That's a lot of money. So not too many people know that. And then 158, so the US and the UK are pretty close when it comes to quantum. So this is talking about that. And then 159, so IDC says $8.6 billion in 2027. So this in specific, they said about 50% compounding annual growth rate too. So 160 is talking about, this is one of those shiny objects as far as Rigetti, actually Rigetti, fusion energy, you know, and you'll see this a lot, hybrid, quantum classical solvers, and advanced compiler optimizations. 161, this was at the end of November last year. And basically what they claim, and I think people are doing this, is you can send a specific task and you'll do most of it classically because it's cheaper. But the things that you absolutely can't do classically, you do on a quantum computer. So this made headlines pretty well. And 162, I talked about this earlier, a bunch, you know, 76% of global HPCs to use quantum by 2023. And then 163, you have Quantinuum, the merger, right? So Honeywell, huge company, it was actually Honeywell Quantum and Cambridge Quantum Computing, this merger. So 164, you have McKinsey report. So I think we've seen at least 3 of these. 165 is worth a closer look. I don't know exactly how much is quantum, but $768 billion. And at the end, you see they talk about the troops. 166 is the 2022. This is the, I think it's what we're under right now as far as, you know, fiscal year 2022 budget. Once again, like industries really came in and, you know, kind of fed off that. This 167 is a good Forbes article. Now, the things with the Forbes, you have to look at the, you know, basically like what's being written because they create so many of them. So some of them are really good. So just use your own judgment. So 168, so this is Rigetti and weather modeling. So the cool thing about Rigetti is they tend to go out after these like really cool pie in the sky things. You got fusion energy, weather modeling, and I haven't heard much from them since these came out, you know, last December, and the other one I think was late in 21 too. Now the 169 is what I'm talking about. So 250 early quantum applications, right? So depending on who you talk to, you know, some people just want to say they ran on quantum. Now, the hard thing is to get quantum advantage in this stage of the game, meaning that whatever you could do could be better done, you know, classically, conventionally, better, faster, cheaper. So 170, this is Amazon. They updated their pricing, you know, so. And so you have, let's see, was that? Okay, so we've seen that. So 157, we saw Google, 76%. This one, okay. So 171, this is probably the most shared article that I have. They claim, or, you know, NSF, who has funded quantum computing since the early 1980s, will have a 2023 practical computer by the end of the year, which is awesome news. Some other cool facts as far as Nobel laureates, and then, you know, basically these other institutes. And so if you look at, so 172 is right off of IBM's website. And it basically, you know, they're dealing with 180 plus different Fortune 500 companies, you know, mix of all these things. It's just like, the amount of collaboration or amount of work, being done is kind of awesome. They probably have the biggest, it's called Qiskit, way of programming these things. Now, 173 kind of hits, home for me, Michigan State, and Purdue. And, this collaboration, probably kind of just getting started there. 174, StrangeWorks, and Quantinuum, who we talked about earlier, that whole thing, that merger. And then, you see more partnerships. Again, I would call last year kind of like the year of partnerships, and this year kind of more movement. 175, $3.2 billion in 2021. Now, that's more than the previous 3 years combined in investments. I put together all this data that kind of shows that, and kind of like that exponential up to the right kind of thing. So 176 is the Competes Act. So basically quantum being part of that. 177, so here's the kind of thing, like when you look at all this stuff, you want to see that things are happening in society, right? I had mentioned, other aspects beyond just universities and your top companies and these types of things too. And actually, Victory Amole was named this 2021 winner of the Wittig Quantum Prize for his work with the Cirque library. So that's just, another thing as far as like kind of like programming in 177. So 178, so this is very interesting, is that the ethical, societal, and legal impact and risk of quantum computing are just starting to be discussed. Obviously, the biggest implication is quantum security. Now, to have awesome security, you need awesome hardware, algorithms, those types of things too. So as we try to defend the country, from outside attacks, because we don't know what they're doing for sure, it's going to help with, like, say, in medical, because that same quantum computer development, to other companies too. So in 179, this twist language, they made a bunch of news. I haven't heard too much more about it, but I think the thing is to prevent bugs in a quantum program. And I read, that there's other information on that too. So 180, this is another DOE thing. So it's talking about the chemistry, right? Chromium defects and silicon carbide. 181. So if you don't know, so IBM has switched to hexagonal, whatever, qubit structures, these types of things. Now you get less performance, but you also get less error, right? So like I said, the hardest things with these is you get theoretically awesome performance, but can you ever get the error down for these things to work? So in 182, quantum accelerators. So that's a big thing. So that's kind of the buzzword the past couple of months is, quantum accelerators into different aspects of existing technologies. So not necessarily trying to, although academia does this, but more trying to work with today's technology, improve it with quantumly. So 183, quantum tech for your industry. This is another Forbes. So this was a good one. And again, there's lots of, Forbes articles out there. So, okay, so 184, this multi-chip system, I think it's the first ever multi-chip. You'd have to talk to more technical people, but I think it's like the whole quality versus trying to get billions of qubits. So 185, so this is a plan, an executive plan. And basically, they have a high like helicopter from the sky kind of approach to all this. 186, this company, Infineon, huge company, 6 new research projects with a bunch of companies. You got 187, 5-second. So the whole thing with this is like companies like Atom Computing, and this is kind of earlier stage than that, it looks like, but we're trying to get the best coherence, and there's many factors in quantum. So 188, so this is the third of the public pure play quantum computing hardware manufacturers to go public. So they announced the deal, and the last I checked is they made their board of directors. 189, So this kind of made, 20 milliseconds. There's certain things that like quantum hardware does very well. And there's other types of quantum technologies like quantum sensors that, kind of does, other things that perhaps you could do storage better, or you could do this or do big data better, or basically process big data all at the same time with 10 different technologies. Hope they don't break. So 190, so this one was very interesting. It's a small thing, and it's quantum communications, but they're sending this to the International Space Station, the SEEK thing. So I included it in the abbreviations before. So 191, when I saw this one, I was like, yeah, things are really getting real. This is like, yeah, it's like, duh, everybody wants to do good work anyway. But DARPA asked Raytheon, BBN, and universities, Southern California, to test limits of quantum, right? So that's a cool DARPA thing. So 192, Q control, 9,000 times improvement. So this is basically dealing with today's error. There's so much error and all this, and it's saying there's an algorithm to account for that. Alphabet, Google, 194, they spun off, Sandbox, and I have another article on Sandbox coming up with like medical. 195, topological qubits, you don't hear too much about, but basically they're saying they fixed a big aspect of it so they can do other things in the future. Now there's other companies you don't hear as much, Alice and Bob at 196, 197. This is high energy physics. So you have 24 authors, Oak Ridge National Lab, Caltech, CERN, MIT, University of Wisconsin, and Harvard. And then 198, I was kind of talking about this as far as like when I see things as far as like a school district, paying to teach teachers how to teach students what quantum computing is, that's huge, right? Because you believe in it. Because we can, it's sometimes in academia, it's just like we see so much stuff, but this is basically secondary school, materials, productive learning and environment. And 199, I just found. So if you haven't gone to it, go to it. It's quantum.gov. And I think this is still the most recent article to download, but it's got a bunch about quantum sensors. So again, between all these technologies and communications and, computing in general, quantum sensors are believed to, have a very bright future. As far as I know, you only need one qubit, and there's all different types of quantum sensors, and technically MRIs and lasers use quantum. So the term, all this classification gets kind of hazy. Now in 200, this is what I was talking about. IonQ, Time 100's most influential companies of 2022. There you go. It's making an impact. So 201, Sandbox AQ, which is the spinoff that I was talking about earlier, Alphabet spinoff. Mount Sinai Health System Collaborate, right? So that's good to see. So 202 is the Chuck Schumer one. So this is upstate New York, trying to get this funding. 203 is, it's this whole quantum communications, and they're saying this has a specific thing with time bin and phase quantum states, these types of things. But that's kind of like the theme right now, quantum communications. So 204, this is quantum volume. So quantum volume, I told you, is a function of high qubits and low error. So I think this is only done on a ion trap quantum computer in the teens, but they achieved it. So it's interesting how big these values will get over time. As we get to, we're 216 with the Xanadu Borealis. So 205, $10 million donation. So this definitely check it out. These donations are going to allow Cornell to enable these things. So Archive, coincidentally, is Cornell. A lot of these articles that I'm posting. 206, this is the first commercial quantum secure network tested. So this preceded the two that we got, the Washington, D.C., and then also the Argonne Fermi Lab one. 207, Stanford one. I would check there's a paper behind that. So 208, Psi-quantum path to 1 million qubits. They originally, a lot of times they'll say we'll get it in 2025. And then I think they backed off that. And then, basically it depends on a number of factors. That's what they're saying in it right now. So USC, ISI, they're saying they're getting more quantum annealing. 210, the neutral atoms available on the cloud. So there's, I think, at least 2 companies that do that. And then 211, atom computing, coherent control of qubits. So 212, again, with the chemistry, a lot of things today depend on the chemistry of cleaning things well, just to get classical computers right. There's companies, huge companies that do that. And 213 is a video. This is really cool because this is so many years after, the 2019 quantum supremacy. And he gave a presentation, John Martinis did, and the types of quotes he said, this clean room fab, like these are important things, right? And they're often overlooked, basically. 214, I basically studied this one. You could do, it's basically saying they use both quantum computer and quantum annealing, and then you would still probably have to talk to them on the phone to find out exactly what's going on. So 215, I mentioned before. So Araceli and Salvador, previous speakers on SoCal Quantum, helped host this, and I think with one of their organizations for 215. So for 216, it's very interesting because, this transition from sports into quantum, it was a good feature on this. I would definitely check that out. That's the whole thing, is like, oh, okay, quantum's making a wave, it's real, people are moving into it. So 217, when I first saw this one, I was like, wow, Pentagon, you don't hear too much about funding, all these types of things. And I think it's partly geographical, the closer to Duke than, SoCal. But it's interesting because they made a big deal out of it, taking time out of their day to go down to Duke to check out the research, kind of like making a statement. 218. So this was on May 4th, the White House, with a memorandum, they announced that, basically they're taking more control of quantum. And, we want to be the leaders in the world, and we want to have awesome security to protect our data from being stolen. Now, not too long after that, I think a couple of days, the QSecure, this company, announced this. 219. So this is the expansion of the collaboration between BMW and Pascal. So that's good to see. Things are growing, and that's one of the conclusions. 220, this is more chemistry. I haven't looked into it too much, but there's all tricks you can do with limited hardware, or like hardware that, we desire that we don't have. So that's interesting checking out if you're in chemistry. 222, this is Air Force Research Lab and GE with kind of like optimization. 222, so this is an interesting, so this Bopeng is talking about reducing noise, and it got an aspect of humor to it. So 223 is good for anybody. So this is 50K. So you have to apply for it. You probably have to have a pretty good team and all that. It's to get rental time on, say, for instance, Amazon's AWS bracket or other quantum hardware rental services or simulator, rental. So 224. So this is where, quantum communications. Chicago expands and activates quantum network. Unprecedented opportunities to transmit quantum information in a real world environment. 224, look at that. So 225, Classique. So this came out June 2nd. I mentioned this before, but basically it says that you can do things that you could never previously do. They've kind of worked things out to, work on AWS. 226, UK based company. So this is overseas, and this is with Orca Computer, which is photonics. 227, 20x increase up to, which is 2,000%, with annealing. And that's what QCI is promising. 228, some kind of maritime stuff. There was a Port of Los Angeles article with kind of the D-wave annealing stuff that seemed interesting. And it's sometimes hard to figure out what they did. I heard from somebody like it could have been just the truck driving up to the whatever. We know the auto stuff has been done. I don't know how much as far as sea, and then as far as air, I don't think anything kind of like direct, but I'm sure it's likely getting worked on. So 229 is the Fermi Lab and Argonne, or I'm sorry, Fermi Accelerator and Argonne National Lab, or they're both national. So 50 kilometers apart. So that's kind of the theme. Here's a good video, 230. And it's interesting, it's just good to see the rest of the world is involved. Our success to a limited, extent depends on theirs too. And we've seen that with, Quantum Latino and the speakers there. And it's just like different people have different skill sets. So 231 is the Washington, D.C. So this is two different ones, two different networks. I would check that out. That's kind of like the hot topic. And then, so just today, 232 or yesterday, inside, no, it's not inside. One of the Quantum Insider. So they posted this, the top 63 quantum computer simulators this year. Check it out. So 233, quantum computing potential to limiting disease. This is the one I was talking about, like limiting the transportation that would get you exposed. But some of the other COVID ones seem more direct. So 234, kind of quantum algorithms for beginners. And then 235, Chicago's doing a lot, hosting quantum and data science workshop in London. That was 235 resources on the quantum computing timeline. Now, the conclusions are the same as they were before. Quantum technologies are a government initiative, and we've seen that, from the get-go. Quantum is a part of our technological development, and I think as opposed to just, just pure quantum everything, it's going to be a lot of hybrids, accelerators, aspects to current high-performance computing, that kind of stuff. And again, we're already working well with annealing optimization problems and, security, that type of stuff too. So number 3, quantum industrial partnerships have expanded. So we saw this with the BMW one, and you'll continue to see it there's just a lot of money being tied up. And in specific, many quantum applications have been funded. And this goes like, Rigetti's, the weather and the nuclear fusion kind of stuff. It'll be interesting to see some of those, hopefully results. Now, my question to you is, where are you? I know it's hard for me. What is your current state with quantum computing? Or what's your relationship with quantum computing? Those types of things. How do government, academia, and industry interact with each other in respect to quantum technology? From your perspective, I'd love to hear from you. And number 3, when will the first practical quantum computer be released? We heard the NSF 2023, but what does that mean? Is that a laptop, a desktop? Do we know? So please email your responses to connect@chemicalqdevice.com.